Right, good morning, good people. Once again, we welcome to the grade 9 mathematics class. My name is Hendrik Makaneta, and we are carrying on with a revision of some of the work that will make it easier for us to write or prepare ourselves for the assessments that we will write next week. Yesterday, we started already with our revision. And of course, we are carrying on this morning. I hope that everyone can hear me. We are, or I see Max still was just asking to everyone, what are we doing today? So Max, your question is now answered. We are just focusing on common fractions, in particular addition and subtraction of common fractions with a view to revise. And I hope that this is something that we can be able to do without any problem. Now, yesterday we did some revision as well on the other work, but today I just want to demonstrate that when it comes to fractions, there are learners who still struggle with fractions, and they want to add the numerators as well as the denominators, especially when it comes to addition or subtraction. And I will demonstrate what do I mean by this. At times you find the learner just, adding the numerators or subtracting the numerators, even though the denominators are not the same. And this is a misconception which I want to clear this morning, just to indicate to you that you can only add or subtract denominators in fact, you can only add or subtract the numerators when the denominator is the same. In other words, when you have a common denominator. So in adding or subtracting fractions, the first thing that you have to do is to make sure that your fractions are written in such a way that they have the same denominator. So at times, you will not always get the fractions with the same denominator. At times, you may get fractions with different denominators, and then you may have to grapple with that. Let's say, for instance, I give you two fractions, 1 over 5 plus 1 over 5. Now, 1 over 5 plus 1 over 5, then the two fractions have got the same denominator, which is 5. So all that you do, you will add the numerators, in this case 1 plus 1, which is 2. So meaning that, as Unkabeti said, your fraction will be 2 over 5. But then let's say you have got 1 over 5 plus 1 over 2. You see now the two are not the same. 1 over 5 plus 1 over 2, they don't have the same denominator. So you can't just add 1 plus 1 and make it 2. And then say 5 plus 2 is 7, the denominator, and then say that the answer is 2 over 7. That will be wrong. You need to first make sure that the denominators are the same. And once the denominators are the same, you can be able to add your numerators. So the example here, this is the first example. I see Unkabet's got that one right. Yes, Unkabet's, I fully agree with you. It will be 7 over 10 because you need to convert or find the LCD, which stands for the lowest common denominator. Now we have got 3 over 5 here, as you can see, plus 1 over 2. And we know that the lowest common denominator will be 10. How do we know this? Because we know this because 5 can go into 10 without a remainder, and then it can also go into 2 can also go into 10 without a remainder as well. So that is how we know that the two numbers 5 and 2 can go into 10, and therefore 10 is the lowest common denominator. But there are, of course, other denominators which are not necessarily the lowest, such as 20, for instance. 5 can go into 20 without a remainder. It can also 2 can also go into 20 without a remainder. So the only difference is that 20 is not the lowest common denominator. In this case, of course, the reason why I'm stating that is that sometimes learners just multiply 2 and 5 to get the lowest common denominator. I'm just saying that it's not always the case that when you multiply the denominators, you will get the lowest common denominator. You will, of course, get the common denominator, but it may not necessarily be the lowest. Right? We are now carrying on, and then by so saying, we need to now convert our denominators into LCD. So meaning that it must be the lowest common denominator. So the 3 over 5, how do we convert this to the lowest common denominator of 10? It means then you multiply 5 by 2. And then we know that 5 times 2 is 10. And then 3 times 2 will give us 6. So the first one there will be 6 over 10. And then the second fraction, which is a half, in order to have the LCD or the common denominator there of 10, you multiply by 5. 2 times 5 is 10. And then always remember that whatever you do to the numerator or to the denominator rather, you must also do to the numerator. So what you do to the bottom number, you must also do to the top number so that you can keep the value of the fraction the same. Remember, we once spoke about equivalent fractions. So in other words, this 3 over 5 and 6 over 10, they are equal. Those are called equivalent fractions. If you multiply the numerator with a number, then you must do the same as well with the denominator. So now that we have multiplied that, you can see half now has turned into 5 over 10. Again, this is an equivalent fraction to half. So 5 over 10 is the same as 1 over 2, or rather half. Now at this point, you can see now that the denominators are the same. And when the denominators are the same, all that you need to do is to add the numerators. And the numerators in this case is 6 and 5. So you will say 6 plus 5 is equal to 11. And then you can see we have 11 there at the top, and then the denominator is 10. Remember, this is we call it a common denominator, or the lowest common denominator. So you just know that once you have added your numerators together, you take that LCD, it becomes your final denominator there. At this point, when you have 11 over 10, you have a fraction which is called improper. So something that is improper is the opposite of proper. So if it is an improper fraction, then this means the numerator is bigger than the denominator, and it cannot stay that way. You need to change it. And how are you going to change it? You will now find out how many times does 10 go into 11. And you'll be able to see that 10 into 11 goes only once, and the remainder is 1 over 10. So the final answer, there will be a mixed number, and the mixed number will be 1 over 10. I mean 1 and whole number 1, and then 1 over 10. Just to recap this example, I said when I started this lesson that there are learners who sometimes make a misconception. For instance, this one here, 3 over 5 plus 1 over 2. Learners who do not understand how fractions work will add 3 and 1, which is the numerators, and then they will also add 5 and 2. And the learner will say the answer is 4 over 7. So please note outright that is wrong. You cannot add the numerators, you cannot add the denominators. The only time when you can add or subtract the numerators, it's when, or it's if, and only if the denominators are the same. If and only if we have the same denominator. So that is the only time, and even that at that point, you just have to add only the numerators, and then you divide the answer by the lowest common denominator. I hope that this example has been able to shed some light in relation to how we solve, or rather complete the addition of fractions. And then I'm just going to take you to another example where we will look at the negative sign, or when we subtract a fraction from a fraction. This was example 1, and then let's go now to example 2, where we need to subtract a fraction from another fraction. Now, the same principle applies even when it comes to a negative sign, or when it comes to subtraction. You apply the same or the very same principles that you have applied in the addition of fractions. Now, in this case, we can see that we've got 3 over 4, or 3/4 there, minus 6 over 7. Excuse me. Now, the lowest common denominator in this case is 28. How do we know it is 28? Because 4 can go into 28 without the remainder. And then the 7 as well can go into 28 without the remainder. It is for this reason that we know that 28 is divisible by 4, but it's also divisible by 7. Now, instead of subtracting 6 from 3, because the misconception that has been created over some time with some of the learners will minus 6 from 3. They will say 3 minus 6 is negative 3, and then 4 minus 7 is 1. So the learner will say the answer is negative 3 over 1, which is not correct. I mean, 4 minus 7 is negative 3. So 3 minus 6 is negative 3 as well. So the learner will say the answer is negative 3 over negative 3, which will probably give a negative 1. So that cannot be correct. Remember, at all material times, you need to find the lowest common denominator. That is what we need to do. And in this case, we have now chosen to multiply the 4 by 7, because if you multiply 7 by 4, you get 28. And then whatever you do to the denominator must also be done to the numerator. Then 3 times 7 is 21, and then 4 times 7 is 28. So 21 over 28 minus, and then 6 times 4 is 24, and 7 times 4 is 28. So you'll have the fraction there, which is equivalent to 3/4 or 3 over 4. That fraction will be 21 over 28. And then the other one, 24 over 28, is equivalent to 6 over 7. Now, at this point, you can just subtract only the numerators. And in this case, the numerator is 21 minus 24, which is -3. And then if you divide that by 28, then you get -3 over 28. So that is one other example where we've been able to demonstrate the importance of the LCD, or rather the lowest common denominator. So from now we are proceeding to the next example if there's no question before you can start working. We also have the whole number. At times you will find that we are adding a whole number and a fraction. It shouldn't be difficult to add the whole number as well as a fraction. Right now I'm just going to show you two methods. The first one is that you need to convert your whole number into a fraction. I'm sure you will agree with me that when you add fractions, it's always better if you are adding a fraction to a fraction, because you are adding the same type of fractions there, be it whether it's an improper fraction or a proper fraction. Now, in this case, once you have converted your 3, you'll see that you can write it in the form of a fraction. 3 is the same as 3 over 1. And we can see that I've put the 1 in red. And then we can use it to find, or we can just add 5 over 4 to that. So 3 plus 5 over 4, this is the same as 3 over 1 plus 5 over 4. And then at this point, you can just convert, excuse me, we are now in example 3. You can just convert your fraction 3 over 1 into 5 into 12 over 4, so that you have the same denominator. Remember, we're looking for the lowest common denominator. And in our case, we multiplied the denominator, which is now 1, and then we've multiplied that by 4. And remember that whatever you do to the denominator should also be done to the numerator. So now that we have multiplied 1 by 4, we also multiplied 3 by 4. And remember that if you multiply 3 by 4, you get 12. And then 1 times 4 is 4. So at this point, you have got a fraction now, 12 over 4 plus 5 over 4. And now you can add only the numerators, which is 12 plus 5, 7. And then 12 plus 5 is 17. And then, of course, this is over 4. Lastly, the 17 over 4 is just your fraction, which is improper. So we just have to now divide both sides. So 4 goes 7 times into 17, goes 4 times because it gets into 16. And the remainder is 1. So that will be 4 and then 1 over 4. Simply put, that's a 4 and a quarter. Now, that is not the only method which you can use. There is another method that you can invoke. for instance, we know that 5 over 4 on its own is it's an improper fraction. So you can actually turn 5 over 4 from an improper fraction to a mixed number. And how do you do that? You will say that 4 goes how many times into 5? Then it goes once, and then the remainder 1 over 4. Right? So 5 over 4 is the same as 1. That's whole number 1, and then 1 over 4. And then if you take the 1 and 1 over 4 and add that to 3, that mixed number will give you a new mixed number, which will be 4. That's the whole number, and 1 over 4. So that's how you solve it. You can either use the method of finding the LCD, or alternatively, you can just turn the mixed number into, turn the improper fraction into a mixed number. Right. We come now to the end of example 3, which was to show that we can just add or subtract the different fractions. That is what we are doing this morning. Now, without any waste of time, I'm just going to zoom directly into an activity which you now have a chance of solving. I hope that the lesson has been very fruitful to you, as we welcome everyone. And of course, let's now calculate the following fractions. We are now looking at 2 over 5 plus 3 over 5. Nosipo, your hand is up. Let me now quickly unmute. All right. Let me give you a chance to unmute yourself. Please go ahead, Nosipo.
Good morning, sir.
Morning, Nosipo.
So I have the answer for the first one.
Okay.
So this is how I worked it out. Because the denominators are the same, I didn't see the need to actually work it out. So what
Okay.
happened was I worked with the numerators, and 2 plus 3 gave me a 5, and then the fraction is 5 over 5, which is equals to a 1.
Okay.
Yeah, and that's it.
All right. I see. And then, of course, Ungabez also found the correct answer there. Ungabez says the answer is 1. And then, who else? Yeah, not only Ungabez, and the rest of those who have managed to solve this. Let's see who else. Amra, yes. Tando Gubani. And of course, who else? Yes, I see that there are 3 of you who now were able to tell that you simply have to add the numerators because the denominators are the same. So if the denominators are the same, all that you need to do is just to add the denominators, the numerators rather, and then you can be able to find a solution. So 2 plus 3 gives you 5, and then 5 over 5 is 1. So King K as well, thank you very much indeed. You have now found the correct answer. So we are now proceeding to the next one where we need to calculate 3, 2 over 3 plus 2, 3 over 4. Can we proceed to this one? Now just to find or just to add the 2 mixed numbers. In this case, these are the mixed numbers. I see that Max, you have converted now the mixed numbers into fractions, or rather improper fractions. Right? I see that there are also 2 hands. Let me check. Unkabetse and Nosipo. Let's now go to Unkabetse quickly. Unkabetse?
Good morning, sir.
Morning, Ngabethu.
So what I'm gonna do first is I'm gonna times at the bottom and plus at the top.
Okay.
It's gonna be 3 times 3, which is 9, and
Okay.
3 plus 2, 3 plus 9, yeah, 9 plus 2 is 11. I'm not sure, sir.
Yes, that's correct.
And then it's gonna be 2 times 4, which is 8,
Okay.
and 8 plus 3, which is 11.
Yes, 11. And the denominator will be?
So the other one will be 8 and the other one will be 9.
Yes. In fact, your denominator stays as they are. So it will be 11 over 3, and then the other one 11 over 2. That's correct. That is correct. And then you need to now find the lowest common, the lowest common, the LCD rather, or the lowest common denominator. Can we find the lowest common denominator? I see that Amber has already found the lowest common denominator. And of course, she even went to the extent of solving the problem there. 11 over 3, if you solve it, the lowest common denominator should be 12. And of course, what you do to the denominator, you must do to the numerator as well. So 3 times 4 is 12. So it means that in the first fraction, you multiply by 4. And then 11 times 4 is 44. Then the other one, 11 times 3 is 33. So once you add 44 and 33, you'll get 77 over 12. So 77 over 12 simply means that you can check how many times does 12 go into 77. So it goes 6 times because it goes into 72. So since we have 77 and then it goes into 72, then it means that the remainder is 5 and then over 12. So your final answer will be a whole number 6 and then 5 over 12. That will be the final answer. I see, Amra, you got it right. Next, I can see that you also made your. I see Unkabetsu was kicked out by the network, but it's fine. I'm sure she'll be back. Bugs also is now doing C. Bugs has now done C. He says it will be 4 and then 5 over 6. 5 over 6. Bugs, let's carry on now. Let's carry on just to demonstrate. I see you just wrote the final answer there. If you want, you can just explain it. Maybe if you can put your mic on and mute yourself just to explain.
Okay, so can you hear me?
Yes, I can hear you.
Okay, so I did this, like it was 4 and 1 over 2 plus 1 over 3. So I changed the 4 and 1 over 2 to 9 over 2. So, and then I times them by 3, and I was like plus 1 over 3 times 2. So, and then I got 27 over 6 plus 2 over 6. And then when you add it together, it's 29 over 6. And then when you break it down, so it's going to be 4 and 5 over 6.
Okay, so your final answer, that's how you arrived at 4, 5 over 6. Yes,
Yes.
I want to agree with you there. The other one, Tando also got 4 and then 5 over 6. The same goes for Amra. Right? I fully agree with you that all that you need to do is just to multiply 2 by 4 in the first instance here, and 2 times 4 is 8, and then 8 plus 1 is 9. So you left 9 over 2 plus 1 over 3. And then obviously the lowest common denominator there will be 6, because out of 9 over 2, you'll multiply 2 by 3. And then 9 times 3 is 27. The other one you'll multiply by 2, and then 1 times 2 is 2. So 27 plus 2 is 29, and then over 6. If you divide 29 by 6, you'll see that 6 goes into 24, which is 4 times. The remainder is 5. And then I fully agree. So thanks indeed for taking the time and the trouble to be part of this discussion. Can we now calculate the different ones? I've given you different problems here, which we can now look at in terms of just calculating or finding the addition. We need to find additions there, and then in all 4 of them. So the first one is 1 over 3 plus 3 over 5. We need to add them together. Remember, once again, as I said when I started, there are learners who still make mistakes of adding the numerator or the numerators and thereafter adding the denominators. For instance, if you are given 1 over 3 plus 3 over 5, the learner will add 1 and 3 to get 4, and then 3 and 5 to get 8. That is wrong. And they will say the answer is 4 over 8 or 1 over 2 if you simplify it. That is not the way in which we should do that. There's another way of making sure that you have the LCD. And then, of course, I see that Unkabetsi is back, and then she has just shown me that she has got 14 out of 15. Unkabetsi there has got 14 out of 15. Not only Unkabetsi, but also Amra. And Amra has shown the different steps. Thank you very much, Amra and Unkabetsi. Then Tando also got 14 out of 15. And it would be nice if I could just, one of you maybe could just explain. But I see Amra has explained it thoroughly on the group chat. That is to say 1 over 3 plus 3 over 5, and then you multiply by 5 over 5. In the first instance, because your lowest common denominator should be 15. And then even in the second fraction, you multiply 3 over 5 by 3 over 3. So you are multiplying 5 by 3, which will be 15. And then 3 times 3 is 9. So at the end of the day, you will have 5 over 15 plus 9 over 15. And then if you add 9 plus 5, you will get 14. So I fully concur. The final answer there will be 14 out of 15. Thank you very much. Can we do the third? Let's do the third collectively. I hope you have a pen and a paper with you. And then we can look at the third one. Whole number 2 and then 1 over 3 plus 3 over 4. That is the expression in the form of fractions, which we need to add. So we're still busy with addition of fractions as well as mixed numbers. Can we find a way to add the two? Can we find a way to add the two? So I see that Tando, in fact, Cleo and Tando already did that together with Umkabetse, who has replied privately. Cleo has also replied privately, 13 out of 40. if you can just explain, but you are right, Cleo, your statement is seconded by Tando, who also agrees with you. The manner in which you go about this is that you will need to firstly convert your fractions into an improper fraction. I'm talking about the mixed number there. You'll have to multiply 3 by 2 to get 6, and then 6 plus 1 is 7. So 7 over 3 plus 3 over 4. Now, obviously, in this case, let's see, how do you get the lowest common denominator? 3 times 2 is 6, and then plus 1 is 7. So you'll have 7 over 3 plus 3 over 4. So the lowest common denominator there is 12, and then how do you get 12? It means you multiply this one here by 4 and the other one by 3. So 2 times 3 is 6, plus 1 is 7. So 7 times 4 is 44. Sorry, 7 times 4 is 28 rather, and then 28 over 3 plus the other one will be 9 over 12. And then you can add 28 and 9, and then of course you divide everything by the, yes, I see that you have got 37. 37 over 12. Is that what you got? Remember, 3 times 2 is 6. 6 plus 1 is 7. And then if you multiply 7 by 4, you get 28. And then the other one, if you multiply 3 by 3, you get 9. So what is 28 plus 9? You take 2. Yes, it's 37. I agree with you. It will be 37 over 12. I agree. So it's 37 over 12. And then 12 goes how many times into 37? It goes 3 times into 36. So the answer will be 3 and then 1 over 12. That's the third one there. So the last one, which is the fourth one, I recommend that what you need to do in this case is to firstly you can add the two fractions together, or you can do it once. There's no need to worry. You can just find the lowest common denominator. And in this case, the lowest common denominator will be 12 once again. Remember, 2 can go into 12 without a remainder. Even 4 can go without a remainder. Even 3 can go into 12 without a remainder. And then when you solve it, you know that the first one there will be 2 into 12 goes 6 times. So if you multiply 6 by 3, you'll get 18. So it will be 18 out of 12. And then 1 over 4 as well, you do the same. 4 into 12 goes 3 times. So this will be 3 over 12. So 18 plus 3 is 21. And then, of course, 21 minus 4, that will be 19. So it will be 19 over 12. See, you've got 17 there. 21 minus 3. Okay, yes. 21 minus 3 there. Minus 4, sorry, not minus 3, it's minus 4. 21 minus 4, yes, it will be 17. So it will be 17 out of 12. Unkabetse has got it right. 17 out of 12 is the correct answer. That is the last one. But now you can also check. 12 into 17 goes once, and then the remainder will be 5. So it's 12 into 17 goes once. The remainder will be 5. So it's 1. Whole number 1 and then 5 over 12. That's the last one. Right? Without any waste of time, I want us to do a subtraction of fractions. Can we just subtract fractions quickly? We have 3 over 5 minus 1 over 2. And then the inverse of that as well. Can we now subtract our fractions? Right, Unkabetse is the first to do that, and she got 1/10. I fully agree with you, Unkabetse. 1/10 is the correct answer. Reason being, the lowest common denominator in this case will be 10, and then of course you multiply everything by 2 in the first fraction, and then you multiply everything by 5 in the second fraction. So you'll have 6/10 minus 5/10. So 6/10 minus 5/10. And remember that 6 minus 5 is 1. This therefore means that your final answer is 1/10, just as Unkabetse has said. Unkabetse has done 2 as well, or B rather, and she found negative 1/10. If you can just explain that, Unkabetse. I fully agree with you, by the way. That's the correct answer. That is the correct answer. Can you just explain that? Right, in the absence of an explanation, I will just carry on to explain it. What we need here is the fact that you have the reciprocals. In fact, you have got the opposite of what we just did in A, where you had 3/5 minus 1/2. So in this case, you have got 1/2 minus 3/5. Once again, the lowest common denominator will be 10. So the first fraction, you just multiply by 5. You multiply the denominator and the numerator by 5. And then the second fraction, which is 3/5, you multiply the denominator by 2. You also multiply the numerator by 2. So you will see that, excuse me, you will have 5/10 minus 6/10. So since the denominators are the same, then you can subtract the numerators. 5 minus 6 is -1. Hence, the answer is -1/10. And then the last one, let's see, Cleo is still trying to type a message. All right, Cleo has found the correct answer there. Okay. Cleo says 1, that's whole number 1, and then 14/15. I fully agree with you, Cleo, and then of course, Unkabetse wrote it in the form of an improper fraction. You are also right, Unkabetse. And then Amra has shown all the steps in the group chat, where she starts by saying 7/3 minus 2/5. That's the first step, and then you now multiply 7/3 by 5/5, and then you multiply 2/5 by 3/3. You will see that 5 times 7 is 35, and then of course 5 times 3 is 15. The other one, 2 times 3 is 6. And then that is 6/15. So it means that you are subtracting, you now have 35/15 minus 6/15. So since the denominators are the same, you'll subtract 6 from 35. So 35 minus 6 is 29. 29/15, just as Unkabetse has found it. And then 15 into 29 goes how many times? Before we get there, Unkabetse is asking, should we always write it in a mixed fraction form? At times, you can just look at the question. They will ask you, if you are not asked, you can just leave it in the form of an improper fraction. But in most cases, an improper fraction needs to be simplified. So once you simplify it, then you know you've got a mixed number now. So unless it is not unless it's specified, so just follow the instructions. If they say to you simplify, then you can simplify that. Now this has brought us to the end of our lesson, and of course, if you have any additional questions, please feel free to send them to our email address, stemdigitalschool@africateamgeeks.co.za. Once more, this lesson was brought to you by the STEM Digital School in partnership with the Sasol Foundation. Until we meet again tomorrow, thank you very much indeed.